So one more numerical for you. There is a stone. This stone falls freely from the top of a tower of height 100 meters. At the same time, simultaneously, one more stone thrown upward with velocity 25 meters per second. Now the question is, calculate where and when these two stones meet. So to solve this problem, we assume like this. Suppose those two stones meet at a distance x or at a height x from the ground in time t. It's an assumption. By taking the assumption, we will solve for the answer and we will go by step. First you take stone 1. Stone 1. So stone 1 falling from the top of the tower to this point. That means it has covered this much of distance. So this distance is nothing but 100 minus x. So 100 minus x is the distance. And as falling freely, its initial velocity is 0. And it has reached to this point in a time t. So therefore, use the formula s equals to ut plus half at square. You may be surprised at why I am taking this formula. Just think, we have distance traveled, we have speed, and we have time. When distance, speed, time is there, the only formula you have is s equal to ut plus half at square. Okay, so the distance traveled is 100 minus x equals to u, which is 0. 0 into t is 0 plus half into acceleration. As it's falling downwards because of the force of gravity, a is g, acceleration due to gravity. So half gt square. So this expression simplified to 100 minus x equals to half gt square. This is equation 1. Now go for stone 2. Stone 2. It is thrown upwards and it has reached a height x in time t. Same formula apply. Then x equals to initial velocity 25 in time t minus half gt square. Why I have kept minus? Because it is thrown upwards or opposite to the force of gravity. That's why a equal to minus g. Okay. So this is the expression x equals to 25t minus half gt square. This is equation 2. Now see the equation 1 and equation 2. We need to solve. Here, instead of x, what I do, I supply this formula inside. So let me do this. From equation 1 comma 2, 100 minus x. Instead of x, I am supplying this 25t minus plus half gt square equals to half gt square. Now, half gt square, half gt square. If half gt square go to the right hand side, half gt square minus half gt square becomes 0. So therefore, you have 100 minus 25t equal to 0. So t equals to 100 by 25, which is 4 seconds. So both stones reach in a time 4 seconds. So you got when they reach, when they both reach. Now we need to find where, means the distance. As you got time equal to 4 seconds, let us go back to the expression. This one, 100 minus x equal to half gt square, which is easier for us. Of course, you can take this equation also, but I am preferring this one. So it implies 100 minus x equals to half g. What is g value? 10 meters per second square. So half into 10, which is 5 t square equals to, we got t equal to 4 seconds. So if we substitute here, 4 into 4, 16, 16 5 is 80. Then 100, 80 comes this side, minus 80 equal to x, implies x equals to 20 meters. So both stones reach at a height of 20 meters in time 4 seconds. So one more challenging numerical for you. There is a stone which has thrown upwards, and after reaching to maximum height, it falls to the ground to the same level. and it has taken total time taken 6 seconds. Now there are 3 questions. One is velocity with which it throws up, you need to calculate. Second one, you need to calculate the maximum height reached, and you need to calculate its position after 4 seconds. Okay, now we will start with the first one, velocity with which it's thrown up. So it's thrown up, so this is the velocity u. As you know that when the ball reaches to maximum height, its velocity is 0. And as throwing up, its acceleration is minus g, as is against to the gravity, minus g, g value 10 meters per second square, you know. So we need to find u. We have v, we have a. One more variable also we know, that is time. Total time taken is 6 seconds, going up, coming down. Then what is the time taken for half of the distance traveled? That is nothing but half of the time. So the half of the time is t equal to 3 seconds. How could I know? This is based on the concept called time of flight. We discussed in the previous chapter, motion. Time of flight is nothing but time of ascent plus time of descent. And the first part is time of ascent. And time of ascent is 3 seconds. Right. So you have, you know, t, a, v. So you need to find u. It's very simple. Use the first equation of motion, v equals to u plus at. Now, this is the v, final velocity is 0, initial velocity need to find, a is minus g, I am writing as the minus 10 into 3, time equal to 3 seconds. So this is nothing but u equal to, if we take u to the left hand side, minus u, minus minus plus, so u equal to 30 meters per second. That's the answer. Now the second one, maximum height reached. Yes, of course you can use equations of motion, but if you remember, we have derived a short formula to find maximum height, and the formula is h equals to u square by 2g. So equals to u square is 30 into 30 by 2 into g, which is 10. 0 0 is cancelled. 2 1s 2, 15s are 30. The answer is 45 meters. Maximum height reached. So h equals to 45 meters. So this is the maximum height, this one. Yeah, you got it. Now see the third one. Its position after 4 seconds. As you know, at this point 3 seconds are over. So till this point 3 seconds are over, and the distance covered is 45 meters. So 4 seconds asked means 1 more second. Let us say this is the distance it has travelled, h dash, for t equal to 1 second. 1 more second. Here to here 3 seconds, here to down 1 more second. So here to here we know the answer. Already we have calculated, we got 45 meters. We need to know this one only. Now if you see this part is a free falling body. In freely falling body, initial velocity u equal to 0. Time you know, acceleration going downwards, acceleration is plus g. So use the formula s equal to ut plus half at square. S equal to ut plus half at square. Now s is nothing but h dash, as we need to calculate. U is 0, 0 into t is 0, plus half into a is g, I am writing as 10 into the time taken 1 second, 1 square. So how much you get? 2 5s, 10, 5 into 1 square is 5, so 5 meters. H dash is 5 meters. So the total distance is nothing but h plus h dash, which is a 45 plus 5, which is 50 meters. So this is the answer. Last problem for you. The volume of 50 grams of a substance is 20 centimeter cube. The density of water is 1 gram per centimeter cube. Will the substance float or sink? So how do we know this answer? We discussed that if the density of a substance is less than the density of water, it floats. If the density of a substance more than the density of water, it sinks. Okay, so we need to check whether the density of a substance is less or more than the water density. Okay, let us do this numerical. We know the density formula, mass by volume. Now what is the mass of the substance is given? 50 grams by volume is 20 centimeter cube. So if you simplify this, you will get 2.5 gram per centimeter cube. This is the density of a substance. But density of water, as mentioned in the question, 1 gram per centimeter cube. So it is very clear that density of substance is more than density of water. Hence, it sinks.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.